Hey pre-calculus students, it's time to go over your complex zeros and reviewing complex zeros of a quadratic function. The first thing that I want to talk about is just kind of a quick review on complex numbers, and you can also see Appendix 11 in the back of your book for a review on complex numbers. Just to refresh your memory, every complex number has a real part and an imaginary part. So what we're going to say is, here is our real part. It's going to stand for some real number, and then we add on a real number times that imaginary number. So this represents a complex number. So the deal is, and this is why I've included this little drawing here, is the notion that complex numbers, as you can see from this diagram, encompass the real numbers and the imaginary numbers. So it is very possible in a complex number for a complex number to have just the real part, and that, as you can see, is all of the numbers that we've talked about. Real numbers encompass rational numbers, which can be, if you guys remember, fractions such as 5/7, or repeating decimals like 1/3. If you were to do 1 divided by 3, you'd get 0.333. Integers, -6. Can't see that very well, can you? Whole numbers, we've got 0. Natural numbers don't show up, but they're a subset of the whole numbers. They're the positive integers. Irrational numbers, pi, square root of 2. Non-repeating decimals all go into the irrational numbers. And then imaginary numbers, here's one, 3i. Let me change my color on the pen here. Let's go to red. So 3i, here we go, that's better. 5i. And then in the complex number system, above that is a complex number, something that has a real part. So maybe it's the real number is 3 plus, maybe it's 2i. So one thing that we have to keep in mind with the notion of an imaginary number is, if I have, for instance, the definition of an imaginary number, what do we do with this square root of -1? Well, we define it to be this imaginary I. That's what we say. If we square both sides, then the important thing to keep in mind is I squared is going to equal -1. So, just as a review, to go over a couple of these operations with imaginary numbers, for instance, if I were to take 3 plus 5i and multiply 3 plus 5i times 2 minus 4i. The operation of this is to do what you would do with two binomials when you're multiplying. The idea of FOIL, so 3 times 2 is 6. 3 times -4i is -12i. Then we have 5i times 2, which is 10i. And 5i minus 4i is -20i squared. So that's where that definition of I squared equaling -1 comes in. So now if we simplify this and combine like terms, we have 6 minus 12i minus, or excuse me, -12i plus 10i is -2i. And then we have minus 20i squared is -1. Simplifying this, I should carry my equal signs, we get 6 plus 20, so that's 26. So we end up with a real part to our complex number minus the imaginary part. So 26 minus 2i is our final solution. So those are just some operations with complex numbers.